And similarly, we'll write the same for loop in CPP as you told, and then we'll run it. Hey everyone, welcome back to the channel. So have you ever thought like how slow a Python for loop can be? So and why does Python struggles with something as simple counting or simple sum of let's say 1 million numbers, while C++ just drives through it and blazes it fast, right? So well, today in this video we're going to demonstrate how much slower a simple Python for loop can be. What are the 4 reasons behind it? Then we'll discuss, do we really need Python? If we need, then when do we need it? So all these topics we are going to cover today. So let's start with a simple challenge. Okay, we'll first just try to code it out and we'll just write the same loop. Okay, in Python and in CPP. We are going to compare two things here, C++ and Python. So we'll write the same for loop which does nothing but just sums up the first 100 million numbers. And similarly, we'll just write the same for loop in CPP as you told, and then we'll run it. All right, and let's compare how fast our things can be. Let me just first start with a simple Python loop. Okay, I'll just run this file. Let's wait. 1, 2, 3, 4. It took around 6 seconds. Just for confirmation, let it just run it one more time. So it roughly takes around 6 to 7 seconds, right? So let me just go to the other tab, and here we are basically compiling this file. All right, I'll just compile this file first, and then I'll just run. Let me just compile it. Yeah, it compiled, but it gave me some warning, but that's fine. I can ignore that. Then I'll just run this file. The time is 0.1489 seconds. I mean, what the hell? Let me just run it one more time. Yeah, that's again, I mean, you see how many times I'm hitting, it's just 0.167. And if I just run it in Python, let's just run one more time in Python just to be sure on our end. It's still slow, still running. Again, it takes around 6 to 7 seconds. So if you notice it, Python is slower around 50 to 60 times. It's slower than the C++ for loop. I mean, what the hell is going on? Why Python is so much slower? Well, the reason is Python slow is, it is not that it's a bad language, not like that. It is because how it works and how it is designed to work under the hood. So I'll explain you the 4 points, like 4 reasons why Python is slower. The first one is, as we know, Python is an interpreted language. So there are two types of language that we have. One is the compiled language and one is the interpreted language. So as Python is an interpreted language, so it does not compile the entire code to machine code before it execution. I mean, how a compiled language work is, if you look at a compiler, let's say C++ is a compiled language. That's what we did, right? Before running it, we actually compiled it using the GCC compiler. We first compiled the file to a machine code. Then we ran the machine code basically, right? So the first step was to compile it and compile it to convert it to machine code. Then the machine code runs directly on the CPU. That's why it's faster. But if you think about Python, what we did is we just ran Python loop.py. It's an interpreted language. That means it interprets each line of the code at the runtime one by one. At runtime, it will just go and parse each line, then try to get the instruction of it. Okay, it will then convert it to the byte code. Let's say I have a simple source code like x is equal to 5 plus 3. Then for this source code, line of source code, it will generate the byte code for it. Okay, like this. This is the byte code. Let's say. Now once this byte code is generated, then the byte code will be executed on the Python virtual machine or a PVM. It's not directly run on the CPU as like C++. It runs inside a PVM or a virtual machine, Python virtual machine environment. Now, why PVM is used? It's just used to make the Python ecosystem, independent of the operating system, because the code runs inside the PVM. So due to this extra steps of running it on the PVM, then convert it into byte code, it adds a overhead and it does not take the advantage of running instructions or the machine code directly on the CPU, which C++ smartly does it and makes it way faster. That means C++ is compiled to machine code and directly speaks the CPU's native language, that is machine code. CPU directly understands machine codes, right? Due to its interpreting nature, executing the byte code one by one at the runtime. The runtime is quite important. At runtime, it generates the byte codes for each of the line and then runs it on the virtual machine. So that was about the first thing. Now the next thing is, next big reason is Python is dynamically typed. It's not statically typed, right? What do you mean by static typing or dynamic typing? For example, here I just declare, let's say x is equal to 5. Python upfront doesn't know that it's an integer. So at runtime, every time the Python executes this code or runs this line of code, it checks the type of the variable at the runtime only. At the runtime, it will try to figure out what is the type of this variable. Then it will do the further things and run the code. But C++ it is statically typed, right? It's not dynamically typed. When we are declaring variable in CPP, we do not declare it like this. We actually declare it like this: int x is equal to 5. We explicitly provide a type specifier of the variable. So because it is statically typed, so when you are compiling the code, right? When you are using the GCC compiler to compile the code here, sorry, G++ compiler to compile the code, the machine code already knows that this variable is a integer variable, so it does not waste time by checking the type at the runtime. So that's a bigger difference. It makes a bigger difference in generating the runtime. The next crucial thing, and it's not directly related to the example that I gave, but it's a way how Python code runs. Python has a something called global interpreter lock. Now what does GIL means? Now the GIL is used ensure that only one thread executes Python code at a time. What do you mean by that? I hope that you have a clearer understanding about the processor and threads, how to create threads, what is the benefit of having threads, what is the difference between process and threads. If you are not aware about that, you won't be able to understand this section. I'll urge you to have a clearer understanding about process and thread, then come to this video. All right? Okay. Now, having the GIL, it ensures that only one thread executes Python code at a time. That means even if you have, let's say, two threads, here I have created two threads, which performs the same CPU task for me. Ideally, what I'll expect, this function is taking, let's say, 10 seconds to execute. So if I call this function twice, one by one, it will take 20 seconds to complete. And if I use threading, right, like this, what will I expect? I will expect that both the function call is executed on under and around 10 seconds only, because I'm using threading. I'm taking the benefit of concurrency, but this is not the case. Even if you have multiple CPU codes, Python's default interpreter does not fully utilize them, and you might expect the program to run twice as fast on a multi-core CPU as you have created two threads. However, due to GIL, only one thread runs at a time, leading to little or no speed improvement in this code. But in C++, there is no such restriction. You can actually create threads and multiple threads, and those threads will run in real concurrency manner, and you will actually see the significant runtime difference of a code. So that's why in order to achieve concurrency, people use multiprocessing in Python. That means you are creating an entire process itself for a different task. In order to achieve this concurrency, I'll use the multiprocessing model. There is a module called multiprocessing Python. It will create two different processes itself. You understand the difference between process and thread, right? That's why it will have its own memory space. It will have its own execution environment, everything run on its own core, right? In a multi-core CPU. That's where it lacks the benefit of using threads in Python. So this is one of the main reason. Now the fourth reason is Python stores integers as objects. It literally stores not only in integers but also all the data types as objects in memory. For example, if I declare something like x is equal to 5 in Python, it will actually it is going to create a object in the memory, and the object contains, let's say, it can contain multiple metadata about the integer. For example, what is the value, what is the type, and something called reference count. I mean, how many times this variable has been referenced by the other parts of the program, so that it will help the garbage collector to clear it out of the memory. For example, if the reference count is, let's say, 2 or 3, that means the garbage collector knows that, yeah, at three places this variable is being used. I mean, this object is being referenced and used, so I cannot clear it from the memory. If it is 0, I can clear it for memory optimization. But in CPP, the integer x, let's say I type it as int in CPP, int x is equal to 5. It is directly stored on the CPU register on the stack memory, so it's completely reduces the memory overhead of storing an entire object in the memory itself, and then causing a burden of obviously, right? So actually this difference is used every time Python increments an integer. Let's say type x is equal to x plus 1 in Python. It is actually modifying an object in the memory. Just imagine. This is the big reason why Python loops are slower. Is there a way to speed up the Python code or the Python loop that we wrote? There are ways. All right. If you can see, you can use NumPy instead of simple for loop. NumPy actually is native to C++. It is written in C, CPP. It runs the logic behind using CPP. So you can use NumPy, or you can use Python or GIT. GIT. GIT means just in time compiling. GIT compiling using PyPy. So those are the two options you can use to make Python code faster, run faster. Still, C++ will beat both of them in many cases. So what is the final takeaway then? Should you use Python then? Or should you stop using Python? The answer is yes, you should use Python when you need quick development and flexibility, and you need to do POCs, you need to show some features to your customer in a short span of time. You can go for Python. You work with AML or data science like NumPy, Pandas, TensorFlow. Those are very much useful and heavily used in Python, because NumPy, as I told, its core is written in CPP, I guess. Yeah, CPP or C, I don't remember. So, and it runs the operation on top of that only. If you are working with A and ML and data science related stuffs, only related to processing the data, then playing with the data using NumPy, Pandas, TensorFlow, etc., you should use Python. And simple, you prioritize readability over raw speed. I mean, Python code is obviously it's easily human readable and anyone can learn it in a shorter span of time. You should not use Python if performance is critical. You are, let's say, preparing data. You are creating your own databases. You are creating your own fast processing services. You are creating your own game engines. You are creating your own real-time application, real-time systems. Creating something like cache server like Redis. Should not use Python, definitely. When you need direct hardware access, you should go for any compiled language like Rust, then or Go, then C, C++, Java. So Java is not a completely compiled language. It also uses a JIT compilation, just-in-time compilation. But yeah, you can definitely opt for those things. The third requirement is you should not use Python when building high-performance applications like databases or services. If you want your backend services or backend servers to perform faster and have a negligible or minimal response time, okay, to a given operation, you should consider, and performance is critical, you need speed in your application, then you should consider not using Python and go for other available options. All right, maybe better to go for a widely used compiled or JIT compiled language, so maybe compiled like Go, Rust, or Java, etc. That's what about the speed comparison between Python and C++. So similar comparison you can do between Python and Go in multiple languages and put them in the comment section, whatever your findings, and let's have a healthy discussion. Okay, and let's explore which language was the faster. Just comparing a loop is not enough, but I hope you understood the core gaps, right? Core differences between a interpreted language and a compiled language. This will help you decide the language, programming language for your next application or the services that you're building. So choose wisely. So if you got to learn something from this video, hit a like. Let's target for 60 likes for this video, and let's target for 3,000 subscribers by the end of this month. Keep supporting. So subscribe to my channel. So if you have any questions, drop them in the comments. I'll definitely answer them. So thank you for watching this video, and I'll see you in the next one. Thank you.